Question, comments? No? And hopefully we'll finish chapter 1 today. If not, we'll have spend like 10 minutes on Friday class to finish chapter 1. We'll definitely begin to study chapter 3 on Friday. I'll post the class notes in the Blackboard definitely before Friday, so you can download and take to the classroom this Friday. So first, continue our discussion on chapter 1 introduction parts and provide you some insights on why we should learn operation management, what we will cover in operation management, what is the usage for operation management in the future. So we have discussed models, especially mathematical models. We will learn a lot of different mathematical models, especially in chapter 3, forecasting, chapter 13, inventory management, chapter 16, scheduling, and something in chapter 8, location planning. So we will learn a lot of different mathematical models used for different functions of operation management. So these are benefits of operation for models. Well, I want you guys to pay attention to here, enable manager to analyze what-if questions. So this is very useful for mathematical model. You think about if we have experiments, like if your major is chemistry or biology, right? You set a parameter, you do the chemistry experiments. That's just one result. You know that's okay, H2 plus, I can't write this. That's H2 plus O2 equal to, I hope it's correct, but a long time ago, right? So it's H2 plus O2 equal to water. So that's chemical experiments, right? If you want to change this formula, let's say you want to get some other product, H2O2, well, then you have to change your inputs. That's for the chemistry experiments. You have to change that. You have to not reduce, totally change the inputs and do it again to get another output. Right? That's the experiments, or can call it physical experiments, chemical experiments. But for our models, if it's a mathematical model we have discussed, we can answer what-if question because if we have a linear regression model, you simply plug in different number of x. You have different inputs, different parameters. We can answer your question, what if? That's the beautiful part and also the money-saving part for mathematical model. Well, if we do the experiments of biology, chemistry, we can't answer the what if question if we don't do that again. Well, now advanced chemical experiment, they also have simulation like bioinformatics. They also can do simulation, but still, mathematical model enable us to answer what if question, which is why it's very important. I can tell you that from my experience, right? Why did the consulting work? We provide the forecasting software, inventory software for our clients like Procter & Gamble. So definitely we provide something not so simple, but some complex model. So if you are a manager, okay, work with us, use our software. You ask, okay, Charles, come here. So I know that you say my ice cream demand next week is 100 units in this fall line. I'm happy about that. But I want to ask you one question. If I have a promotion, if I decide to do a promotion, what will be your forecast for ice cream? Well, you don't need to analyze the historical data again. Since you already have the promotion as a parameter, now you set equal to 0 because there's no promotion. You only need to change this parameter from 0 to 1. You say, okay, manager, okay, Jason, let's see that. Okay, let's change the promotion. Let's say promotion is a parameter, say it's 20y. Y is promotion. Now y equal to 0, we know, okay, what's the result? If promotion we set equal to 1, then what should be your demand forecast? You can simply answer this question. And after I train my users, they don't need to ask me. We have the function in the software. You just change the parameters, right? If you change these parameters, you will see what if results. If you have promotion, discount, whatever, or whether if we have this parameter in our model. If we don't have this parameter in the model, then we have to rerun our model to add this factor. If we already have this factor in our model, we can easily answer what if question. Why is very important? Because you can adjust. Now we have the forecast or whatever model is based on our current situation. Now, if enable you answer the what if question, you can decide whether you want to go to the promotion. You can decide whether you want to provide some discounts. And you can decide something in advance, which definitely can be very beneficial for your business. It's clear for you? Okay. Question? Clear? All right. So I want to keep that in mind. Okay. Is the function, if you use some software, most likely you have some ERP system in the future, you want to use that function to answer what's if. One thing you must know that is if you log in your DAS system, it also has what's if function to run your DAS. You tell what's if happen if you only select 2 courses in this semester, whether you can graduate in the next spring. If you select 3 courses, whether you can graduate. So it's also give you a scenario, okay, which is very good. Okay, some details of different quantitative methods or models. We will learn some models in this course, but not all of them. But all the models listed here, they are widely used in the real world operation management. That's what I can say. Unfortunately, we don't have enough time to introduce all the models in this class, but we'll introduce some of them. The first one is a linear program, which unfortunately, I don't have time to introduce linear programming in this class. I want to ask any of you know what is linear programming? Any of you? No? Never heard about that? Linear programming? No? Heard about that?
I think.
You think? Okay, so let's give you a simple example. What is linear programming? Linear programming is an optimization model. So since we are in the school business, okay, let's say for many situations, what is our goal? It's maximize what? Business school student, maximize what? Profits, right? This profits you can write in different way. Let's say you have 2 products, X and Y, okay? The unit sale price for X is $3 and the Y is $5. That is very simple, right? You maximum, let's say this revenue, okay? We don't consider the cost, but you can also think about the profit is $3 per unit, profit is $5 per unit for Y, right? So we want to maximize its profits, okay? But then you can say, well, order as much X or as much as possible as Y, okay? But you have some constraint. One constraint you can think about is inventory, right? You have warehouse has a constraint, right? So you can't say store 1 million units of X. No way you can install that. And then you get the volume or dimension of X and Y, and then say you have some constraints for the warehouse. Let's say 100X plus 50Y is equal to 2,000. Let's say this 2,000 square feet. So each X for 100 square feet, and each Y for 1,500 square feet. Then you know that you can't hold a lot of X and Y. Right? That's a combination. If you hold more X, that has constraint of Y. And you have another constraint, say, let's say some other constraint, say, handled by your employer. You have some employer have to package or do some work for X and Y. And each unit of X takes, say, like, say 30 minutes to handle X plus 40 minutes to handle Y, and the total hours you have for X and Y, let's say it's 1,600 minutes, which is in fact, I think it's 1,800 minutes, so which is 30 hours. So this first constraint is warehouse constraints, and the second one is labor to handle these 2 products. That is very simple model. You only have 2 products. You have maybe a convenience store, very small warehouse. You can handle X and Y, and you have some employer that is like the 30 hours labor. So probably you have like let's say 4 employer work for you. So that is, you can think about this is minutes. Then it should be 30 hours. Okay, 30 hours. So you like 4 employee work for you. Then you can that's your constraint to handle X1. Our goal is very simple, right? We want to maximize our profits. Okay, this combination of XY. Does anybody know how to solve this problem? Probably not. Right? Even it's a very simple problem. You will see this problem in the future for sure. You want to maximize your profits or minimize your costs, but definitely there's some constraint. You can't always increase your units of sale, something like that. I can tell you this is the very simple example of linear program. The definition of linear program is that first we have the objective function, which is defined by maximize or minimize a function. But the function is linear. I believe everybody here knows what's called linear, right? Linear, that means knows the quadratic, knows the cubic, knows the exponential is linear. 3x plus 5y is a linear function of x and y. So when the objective function is linear, moreover, the constraints is also linear. You can see here, 100x plus 50y, let's go to 2000. 30x plus 40y, let's go to 1800. They are both linear constraints. It's inequality. When we talk about constraints, we mean inequality. You have some constraint greater than or less or equal to, so that's inequality. When both the objective function and the constraints are linear function, it's called a linear program problem. I can tell you, you can learn in the future course, you can also just go to websites, wiki or some tutorial, very simple. You can use Excel free to solve this problem in 1 second. Just put this constraint in Excel, solve that in 1 second. Very simple. Question?
Is optimization like this linear programming the same where you just set one side equal to 0 and solve through that way? Or is that different?
What do you mean by you say one side equal to 0? Which side equal to 0?
Where, like either where you're setting it equal to 0 to get the y equals, or where you're setting like...
What I said is the constraint is inequality, less or equal to something, or greater or equal to something. To solve this is so simple. If you want to learn how to solve that, probably there's some course in industrial engineering departments. It's called simplex model. So if you use your right hand to solve that, it's a step by step. Even that this simple problem probably will take like 10 to 20 minutes to step to solve that. But that's a way to guarantee you can get optimized solution. That's the beautiful part for linear program. We can guarantee to get the optimized solution. So since that's algorithm, even that if we solve step by step, it's pretty tedious, take out some time. But since it's a step-by-step procedure, so software can handle it very well. Excel or some free software, then we can solve very simply. But how do you solve that? What's algorithm? We have to spend several classes to teach that, so which I don't have time in this course to teach that. I hope we have some course to teach that, because when I was in Purdue, we have a course to teach optimization. That's beyond we have statistics course, business statistics course, and also it's called management science undergraduate course. Then we are teaching optimization, definitely include linear program in Purdue. But here we don't have this course. But I still want to open this window for you. Okay, don't let so you have interview, you are working in the future, you are scared of that. Nothing to scare. That's it. If you need to learn, I believe spend 4 to 8 hours through and tutorial websites, you can learn by yourself. It's not hard. Question? Comments? Good? Okay. Unfortunately, we won't go through this process, but you know that this is called a linear program. It's optimization tool, which we won't cover in this class, but I hope you remember this is another powerful tool. Basically, that's two powerful tools for solving different models of business problem. One tool we are very familiar with that, which is statistics, like linear regression model. Another tool is optimization. We are now so familiar with that. I believe some econ students, they learn some advanced econ class, they know that. But probably knows in management track. But we're not scared that. We know that's how to do that, right? In the future. Queuing technicals. Still, we won't cover in our class. But I want to introduce what does queuing technicals mean? It's used widely in a waiting problem. Think about we go to a Bank of America, right? So BB&T, you want to deposit our check. I know nowadays probably for deposit check you are doing ATM. Let's say we will do some foreign transaction. Okay, we have to do that in the counter, right? So that's two lines in BB&T. You have to decide which line you want to wait, right? Like Walmart's 4 lines, same. Which line you want to wait? That's a queuing theorem. So that's queuing technicals. We are trying to minimize the average waiting time for the customer. You think about if you are a customer, you go to a line, there's only 2 people in front of you. You think you only need to wait 5 minutes to get you. Unfortunately, that's one customer's he or she costs the counter or cashier like half an hour, you can be very frustrated waiting this line. You will be very frustrated waiting this line. That can create problem. One simple solution is already implemented in a lot of bank or service. You can see that everybody waits in the same line, right? That's several cashier, like say 5 cashier. So, okay, if one cashier stuck on one customer, even 2 cashiers stuck in 2 customers, still the whole flow will move. As long as some cashier they're very efficient, some customer you are full. But if you separate, like say 5 different lines, some customer can be stuck, wait for error for the front customer. That's a simple solution. That's something called a pool solution. And some other technicals in the queuing technicals, you can learn. Hopefully you will learn in the future. But I want to let you know that queuing theorem is widely used in the server industry when you want to minimize the average waiting time. Because average waiting is very important. Some customer they wait too long, it's not very good. You want customer to be treated fairly, right? Everybody waits for average wait 5 minutes. That's the queuing technical. The third one we'll definitely introduce a lot in the inventory models, which is chapter 13, inventory management. We'll introduce like EOQ model, economical order quantity model, EPQ model, and safety stock model. I will do that. Don't worry about that. That's just one of the most important parts we'll cover in this course. Project model. If you're a project manager, you need to learn that. But we won't cover in this course. Forecasting. Oh, that's we'll begin the journey from Friday. Lots of models. I want to first remind you guys, this is, I heard a lot of complaints in the past 3 years when I go to forecast. So just be prepared. Okay, if you have any question, let me know or ask around as soon as possible. Statistical model. We use a lot of different statistical model in chapter 10 for quality control and other different chapters. You guys are very familiar with statistical models, right? So that's pretty much important models widely used in operations management. Well, unfortunately, we can't cover especially linear programming. Hopefully, I hope I will open some course in the future, even elective course, to cover this part in undergraduate level. Okay, so model definitely have a limitation. No matter how fancy is your model, you will have some limitation. Well, it's usually quantitative information emphasized. Okay, we ignore some qualitative information. The reason sometimes we ignore or we don't consider qualitative information is because for the mathematical model, it's hard. Sometimes it's hard to implement, to model the qualitative information into our model. For example, okay, let's say we want to make a forecasting for the demand of the shoes, right? Then we definitely know that, from my personal opinion, girls and boys have totally different demand pattern for shoes. Well, generally speaking, most likely girls' demand for shoes is much higher than boys, right? Then you know that, okay, that's a gender difference, which is the qualitative factors. And then anybody know how to add this factor into our model? Let's say if that's a linear regression model. So our demand for shoes, y equal to, let's say this is 3x plus 5. This is without gender. If we consider gender factor, can we add this gender factor, which is qualitative information, in our model? Is that possible? Is it easy to do that? It's hard, right? First impression is hard because, okay, how can we add the gender male versus female into this model? In fact, in this simple example, we can add this factor into our model. I'm not sure whether you have been introduced in the business statistics too, but if not, I can tell you how to implement that. Use just another factor, let's say Z is a gender. And you set Z equal to 0. This person is a male. Female, Z equal to 1. Then in fact, you have 2 different linear regression model, which is 2Z. Which is means, okay, for male, your demand for shoe is 3x plus 5. for male when z equal to 0, right? For female, it's 3x plus 5 plus 2 when z equal to 1, which in fact is 3x plus 7. So demand for shoes for female is higher than male. You see? That's how we can handle this called binary variable. If we only have two variables, male, female, okay, right? So adults, children, that's we can handle that. But if this qualitative variable has more than two realized value, then it's hard to handle. We can still handle. I won't go very deep into that, but it's hard. Think about if you have a range from like from age from 0 to 18, 18 to 25, 25 to 35, 35 to 45, 45 to 60, about 60. Well, we have to do the survey. We can see that a lot of survey have this range of the age. That is really hard to handle. But what I want to say is that sometimes, like this simple example, male, female, we can add this variable into our model. In fact, it's become two models. But it's easy to understand if we were just one model, right? But for most situations, qualitative information is hard or sometimes impossible to implement in our mathematical model, which definitely is a big limitation because we know, like this example, if we consider the demand for shoes, demand for purse, right, demand for jewelry, we can't mix male and female together, right? We shouldn't do that. If we mix them together, we definitely have a bias. Right? We should separate these two groups, right? Then have the model. Similarly, if you consider like games, like PlayStation 4, okay, Xbox, well, totally different pattern for male and female, right? Similar for different age, right? For like health insurance, right? Medical machine, something like that, different. So in many situations, we should consider qualitative information in our model. But unfortunately, we have this constraint or limitation in our quantitative model. That's what we should keep in mind. The reason is that it's really hard. It's not because it's not important. The reason many times it's really hard, okay, to implement the qualitative variables information in our model. That's a big limitation. That's why you guys have the marketing, consumer behavior. That's some course we study about the qualitative information, human resource factor. That is hard to handle by mathematical model, right? We want to get some sense of that. Okay, second limitation. Even we have a very good model, but these models can be incorrectly applied and the results misinterpreted. Okay, this is widely happening in industry. Right? First, clients or even yourself use some software, you don't know. You don't know how they get the model. First is whether you trust this model. I experienced several times. Okay, I build a model for a customer, but since you can't explain step by step how to get this complex model, we definitely give them the software. You say, okay, you just press the button, you will get the demand for next week. Okay, then some customers just say, okay, I pay you money, you must give me very good results. They just trust you. But there's some customers, usually they are well-educated, customer, they suspect your results. They can't just trust, click the button, you get the result. They will ask you, why? How to get next week's demand for the ice cream? What's the difference between you get next week demand for ice cream with next week demand for chicken wings? Do you use the same model? Different parameters. We have to go through step by step to explain to our customer. So if you do that for your manager, same. If you understand the model, you have to explain to your manager. Okay, even after explaining to your manager, to your client, still, they can misinterpret your model. Right? For example, when I work for our clients, we provide a demand forecast for next 13 weeks. So it's okay, like today, it's this week. So we from the forecast from next week until November, some week in November. So we provide 13 weeks demand, no matter what's your product. Chicken wings, ice cream, okay, doesn't matter. We provide a 13 weeks forecast. Then your manager has to understand what does it mean for 13 weeks. for 12 weeks, we have different leg. We call it leg 0, leg 1 until leg 13. You have to understand what does this mean. Which means, okay, is if leg we do 3, that means 3 weeks later. It's not next week. Okay, 3 weeks after next week. You have to understand that. And you also have to understand what's the meaning of that. For example, we have y equal to 3x plus 5. It's very simple model, but we have discussed. You have to understand first whether it's a weekly forecast or daily forecast or monthly forecast. You can make some mistake, some manager or client. Second, what are units of that? You just tell me this is not enough. Is that units? What's the unit? Measurements of units. It's a package, pennies, or just one small piece of that? Right? Different packages have totally different meaning for the demand. Right? And some other information you have to answer me. So even you have very good models, since you guys are from school business, very important for you to explain to your client's manager. Definitely, first, it's very important for you to understand by yourself. You have to be able to explain. And in many situations, there's some vendors working for you. They provide you some model or some software. You should ask them, like my clients ask me. In fact, they challenge me almost every day. Sometimes at 8 a.m. in the morning, I drive the car, receive a call from your neighbor, say, Charles, why this doesn't work? I say, please wait for 20 minutes after I get your company. Okay, but that's common. Okay, I receive a call from India on the Middle East. Okay, email almost every day. I receive 100 emails when I did consulting work. So by the email, I want to ask you guys, since I work in consulting work before, so feel free to send me email. I'm not a person bothered with email. I check my email almost, if those error means at least every 10 minutes. Okay, so if you have any question, you say shoot me an email, Charles. What's the problem of this one? Let me know. Okay, because when I do consulting work, spend a lot of time every day to answer the email, which usually is long emails to have a lot of screenshots to explain to them. Okay, so that's a limitation or I would say potential risk of model. Questions? No. Okay. The last one. You will use the model which is very good model, can't guarantee a good decisions. Yeah, that can be because decision making is not just the good models. You have to consider other factors, human factors, and your strategy. You can't just, okay, we have the demand forecast increase for ice cream, then we need to order more ice cream. It's totally different. Think about it. If ice cream demand next week, which doesn't mean you should order more, because you have some other constraint. First one, inventory. Right? Whether you have the ability to hold more ice creams. Right? Second, transportation. Whether you have enough trucks to ship those ice creams, or if you have to ship more, you probably will pay extra for drivers, whatever. Then it's whether it's worth to do that. And also human resource, whether you have enough employees to handle the more demand. So perfect model tell you, okay, your ice cream demand will increase dramatically next month, which doesn't mean you should increase your order quantity of ice cream. Most time you should, you should satisfy your customer, but you should also consider other factors. That's why a perfect model can't guarantee good decisions, right? That's a limitation. Any question or comments? Good. Metrics and the trade-off. We'll talk about several different metrics in this class. Okay. Since we're in the school business, we definitely know that we talk a lot of profits, maximize our profit costs, minimize our costs. Productivity, forecast accuracy. For forecast accuracy, is that the more the better or the less the better for forecast accuracy? The more the better, right? We want to have a higher forecast accuracy. Okay, great. And we will analyze a lot of trade-offs. That's one example I want to ask you guys. Is the inventory. So if we carry more inventory, we will achieve, usually or hopefully, will achieve a great level of customer service. Then what is the trade-off if we carry less inventory? If we carry less inventory, what's the benefit we can get?
Less holding costs.
Holding cost is
Lower.
lower. Great. We generally save some costs. Is there any other benefits? Less inventory.
Well, I guess it goes with. Never mind.
Holding cost. Yeah, definitely holding cost is the major benefits for less inventory. Some other like the easy to handle, right? And something like quality control because you have less inventory, right? So that's the benefits. So the benefits of carrying more we have already discussed here, right? Let's think about another scenario. Capacity planning, chapter 5. You know that, okay, your demand will increase gradually. It's not increase dramatically. You know your demand will increase gradually for the next few months or next few years. And you have two choices: buy a machine, advanced machine, to satisfy the capacity demand, but in advance. Because your demand, one machine can produce 1,000 units per day, but your demand is like 100 units per day increase, 100 units per day increase. It's gradually. Okay, understand what I mean, right? So you have this trade-off choice. First, you invest the money now to buy an advanced machine. Okay, now, or you wait, maybe after 1 year, you say, okay, demand, you can't satisfy demand at all, and then buy a machine later. There are two strategies. What's the trade-off? What's the benefit for the first one? You invest money to buy the machine now. What's the benefit? You know your demand will increase gradually. So you want to say, okay, I want to move early and buy the machine. Want to make sure every customer is happy. Then what's the benefits?
No problem with meeting demands.
Meeting demand, customer service, right? If we have a demand now, we will cut machine now, we'll make sure every customer will get whatever they want. Okay. What's the benefits if we wait a year until we really can't satisfy our demand, then we buy a machine? What's the benefit of that?
Cost fundraising.
Cost, right? We can delay our investments until 1 year later, and also we will save some money because we have the demand increase gradually. If we invest machine now, in the beginning several months or even a few years, the efficiency of the machine is not 100% because we don't need to run that 24 hours. Okay, we know that after 2 years we need to run the machine 24 hours, but now no. If we wait until 1 year later, we will disappoint some customers. That's a trade-off, right? Some customer in the next 1 year, they can't get their stuff they want or get some delay. But we will get the machine and has a very high usage rate for the machine after 1 year because our demand already increased to a step that we really need this machine. That's a trade-off. So there's a lot of trade-off in operation management like scheduling, right? Inventory management, we'll discuss transportation, trucks. Okay, let's talk about another scenario trade-off. So if you are doing manufacturing industry, you have two choices about your logistic management. First is you own your own trucks and drivers as your employee. The second choice, many companies do outsourcing. Outsource your transportation parts to USPS or UPS. Then what is trade-off? What is the benefit if you own your own trucks and driver? Like Walmart, Food Lion, they did that. You can see they have their own trucks and drivers. Right? What's the benefit for this choice?
For owning your own truck?
Yes. No benefit?
You have access whenever you want.
Yeah, you get to delegate what time and when and where the trucks will be able to go and leave.
Yeah. Tight control, right? You have very tight control on this transportation department because it's your department, right? You probably will have more, hopefully you have more information about where the trucks or drivers are. You know, any emergency happen, you have some backup plan, right? Because you have some other trucks or driver. Then what's the benefit?
You said, what's the control code again?
Yeah, the control, the tighter control.
Oh, title control?
Yeah, tighter control on your transportation department. Then what's the benefits if you outsource to, let's say, UPS?
No startup cost.
Yeah, this can be. It depends on your skill. Maybe Walmart is not save their cost if they
Well,
also
the startup cost, like you don't have to buy a bunch of trucks.
Oh, yeah, startup. That's great. In the opportunity cost, definitely. Even Walmart opportunity cost first initially is very high. Yeah. What else? Any other benefits if you outsource to UPS, USPS?
You're not really responsible.
You still need to be responsible. I understand what you mean, but still, you think about that. Finally, it's your responsibility. Your customer don't care it's UPS or your truck dealer. If I can't get the stuff I order, I blame on you. I don't blame on USPS because who cares USPS or UPS, right? You don't care Amazon sending you by USPS or FedEx, right? You will complain with Amazon, right? Sometimes really USPS problem. But I understand what you mean. You say for the transportation departments, it's their responsibility, right? Then you have some low risk. For example, you don't need to maintain your truck, or maybe your unemployment rates or some turnover rates of your drivers that you don't need to worry about. But still, remember, it's a trade-off. Very good discount is that it can be a benefit, but it also can be a risk because you are out of control about transportation, right? So another benefits I'm thinking about is professional service because they are doing the logistical transportation for more than 100 years, right? They know much better routes or load packaging than you. So especially for small companies, you will benefit from their service. Even sometimes more expensive, but still better than you do by yourself. So there's a lot of trade-off we'll discuss in the rest of this class. All right, so this is an intro topic. We'll spend some time to discuss this slide, degree of customization. Okay, so relative to some standard products and service, customized products tend to be more labor intensive because it's customized with the different people or at least a very skilled worker to handle customization for products. Usually it's more time consuming to produce a highly customized product. More highly skilled people need flexible equipment. Usually we have a lower volume outcome, have higher price tag. You see, everything this here seems for me a negative part. If we talk about the cost, higher cost, or you have hopefully you have a higher price. Definitely, we have so many higher components for the higher cost, and we have a higher price. One question: why we want to have a high degree of customization? Why? Why we want to have a high degree of customization for our products or service?
Customer satisfaction.
Uh-huh.
Customer satisfaction.
Customer satisfaction. Yeah, that's good. Customer like customization. What else? It's already mentioned here. In fact, what's the benefit? Higher customization.
Stand out.
Stand out
Higher
from
prices.
your competitors. Definitely great.
Higher prices.
Higher
higher
price.
profit.
Yeah. That probably this is our final question. Why we want to have a higher customization? We should have a higher price. But nowadays, not so nowadays, I would say, in our life, we see more standard products than customer products. Well, it probably depends on our class. If I'm Bill Gates, probably most products I use are customized. But for, I believe, all of guys, including myself here, in our daily life, we use more standard products than customer products. Okay. But could you give me some example, maybe use, but maybe you know that's customized products or service? Any example? Or highly customized products or service?
Like cars.
Cars? What kind of car is customized?
Well, you could get any car customized.
Yeah, that's I want to discuss. In fact, I don't think, that's my personal opinion, any car is highly customized. I know what you mean. Like say,
Mini Cooper.
it's harder to choose a brand because if I say this brand is not customized, I don't know. I mean, let's say we don't have any Japanese student here, right? Let's say Toyota Corolla. Okay, I don't think Corolla is a highly customized product. I didn't say it's not customized. Okay, first Toyota Corolla. Toyota has a high level brand car, but Toyota Corolla definitely is not the high level brand car, right? It has some customized, but we can discuss later, but it's not the highly customized. But if you talk about Ferrari, Lamborghini, like Porsche, definitely, okay, many cars, they are highly customized. So it depends. The automobile industry definitely, for high level, they are very luxury industry. Okay, for luxury industry, usually you will see high customer. I hope I didn't offend any people right here, but that's just my personal opinion. Okay, Toyota Camry Toyota Corolla is not so highly customized. But I agree with you for the automobile industry, luxury car, highly customized. What else? Any other industry or service?
Shoes.
Shoes. Definitely luxury shoes. And for girls, you must know that purse, right? That can be very luxury. Diamond, right? I'm not sure. Maybe some of you already gets married or proposed, right? You know that's where cost you a lot of money, right? Because I mean, boys or men, a lot of money. Those girls as well, right? You get just to receive that. So that is okay. I didn't get any ring from my wife, so maybe it's not common. I should ask her why you didn't give me any rings. I don't wear any rings, but it's weird. It usually costs a lot of money. So it's a lot of customization, like 5C, cutting, color. I already forget what's 5C, but it's like high standard. You can choose like the waist. Okay, a lot of things you can choose, highly customized. So that we want to get a higher price tag. So degree of customization, like we think about, like okay, the car industry have a significant influence on the entire organization of your products or service. Right? The process selection. If you are higher custom products, the process can be very complex. Job design. Okay. If your standard one is very simple, easy training, everybody working in the production line. It definitely affects marketing, sales, accounting, finance, information system. You think about it, the luxury brand have totally different strategy for marketing, for sales channel, right? Even for finance strategy. I'll give you an example. For a luxury brand, they made a mistake. Okay. Does anybody know the brand of Tiffany? Raise your hand if you heard about that before. Tiffany. Tiffany.
You're talking about the diamonds.
Somebody don't know? Don't know Tiffany? Do you have a girlfriend? Just kidding. Yeah, maybe you have a girlfriend who is not interested in Tiffany, but for most guys, at least for me, the reason I know Tiffany because when I had a girlfriend, I have to know that's a brand called Tiffany, right? It's a very famous brand for which industry? Jewelry. Right? So that's why usually boys we don't know. Okay, most of us, right? We don't know. So Tiffany, they are a luxury brand. You know that their jewelry are very expensive. There's some other brand even more luxury, like Cartier is more luxury than Tiffany, but Tiffany is still a high level brand. Okay. Tiffany, most of their products are highly customized. They have different like rings, necklace, highly customized. So several years ago, Tiffany produced a product. They want to target the middle level, even it's probably low level market. They say, okay, I want to attract like teenage girls or college girls, students. Okay, they can't afford like thousands or even $10,000 to buy a necklace or rings. They has a product, necklace. It's only several $100s. And it's pretty cheap in their level, in Tiffany. Okay. So this product was so popular that teenage girls, college girls, they rush this Tiffany, a luxury brand, very good quality, fantastic reputation with no so expensive price that goes a necklace. So many people guess that. Then the product itself is so successful. Before I go to the next part of this story, do you see any problem here until now? Very successful products get a lot of profits for Tiffany. Any problem?
The demand is too high.
Demand is too high. They can still satisfy that. I can tell you. You want brands, no problem. They can still satisfy demand for the necklace.
Okay.
Any problem?
Right.
Price is good. Because Tiffany, the brand, they can charge you a little bit higher price than it should be, like iPhone charge for us. So they enjoy that.
Maybe the image.
That's right. Image, the brand, okay, the reputation for this luxury brand. You can think about what is the major customer group of Tiffany?
High level. Yeah, high in volume products.
What about the age? You think about the age of their customer.
Like 30s and up.
Yeah, maybe about 30 to 60, something like that, right? Main majority, we are not talking about some princess they can have Tiffany when they are 5 years old, but the majority, okay, is like middle age or above, right? What's their feeling? If they see teenage girls, college girls, not all of them, most of them can probably don't have, but some of them, maybe they have some concern. That's true. Many customers, they complain about that. I'm your loyal customer for 20 years, 10 years. Just one night, after one night, a lot of teenage girls wear the same brand Tiffany products. A lot of people wear that. We'll switch to Cartier for some other brand. They switch to Tiffany. When they threat, that's really threat because they have a lot of bargaining powers. So that's customer group, right? And then Tiffany finally has made the decision. They recall, it's not recall. They buy back all the product they sell in the market. Then you can't force customer to sell it back with a higher price. You 3 months, I want to buy back with 20% more price I sell to you. They did that. Not all customer return, but you know that some money teenage girl, okay, well 3 months, I can earn some money, sell back to you, return. So finally, Tiffany lose a lot of money on these products. Also, still harmful for their image, even they buy back. So when you are in the luxury brand industry, your strategy is totally different with like standard product service. You should definitely keep that in mind. That's the case I learned those from operation management. When I was in Purdue, I was in the MBA marketing class. That's the case I will remember forever because that's a very good case for marketing. Even I'm not in that major, but I really like this case when I was in Purdue. Okay, so you have to learn that. We only mention here affects your marketing. You should keep that in mind. When you're in the luxury industry, totally different. If you also think about like, not really so different, but Apple. The Apple sales channel is very different with a lot of other companies like even Samsung, even Motorola. They're different. Apple has Apple Store. Do you find any maybe? I don't find the Samsung store a lot. I don't find Motorola store a lot, but we do find a lot of Apple store. Their own sales channel. They did that for a reason, right? For their image, for their brand. Okay. So if you are in different position in the market, you definitely should use different strategy. In marketing, sales, and also definitely in our operation paths, totally different. Like we're talking about inventory, right? Apple can use this inventory strategy. Supply less than demand. They're happy about that. But if you are Motorola or Nokia, probably it's not a good strategy. Okay. Any questions or discussion about this path? No? Priority. So, priority is very important, not just for operation management or management, it's also for our daily life. Pareto phenomenon. By definition, Pareto phenomenon is that a few factors account for a higher percentage of occurrence of some events. So that means in our management, in our organization, the most important thing are only a few factors, like the R&D, like human resource, our employer, maybe some other factor, inventory turnover rate. We don't need to spend a lot of time or money on tiny stuff. Similar here for our life. Okay, our life, different stage, we have different priorities. Right? When we are kids, okay, most likely our priority is study. Right? Study. When you work in the industry, that's different. You still continue to study, but other skill, experience, communication can be more important than the ability to study and learn things stuff. But in college student, maybe it's a balance. I believe that college students is the best time of the life. From my personal experience, I still want to go back. There's no way I can go back, but I think my college life is one of the most beautiful parts of my life. The reason I think so is that, like you guys now, you have a lot of things to explore. Academic, study, very important, still top priority in your current stage. Experience, some of you already have internship, already work full-time or part-time. You gain some experience for real works. And the friendship, well, I personally think that college friendship can last for the whole life. I personally have this experience. I can't guarantee for the rest of like 40 years, but I have a lot of friends last until now, after graduate for 12 years. Definitely romantic relationship, definitely it's a good time to explore. I didn't explore too much when I was a college student. Okay, I don't feel so regret about that, but I hope you guys can grab this opportunity. Romantic relationship. And the last one, different activities. Explore. Please explore. I'm your faculty, but I encourage every student to explore outside of the classroom. Different club, sports, a lot of things, volunteer, try to explore. That's the best time of your life. But still, we have priority, probably class, right? Academic. maybe romantic relationship should be and can be a priority in your quality life. But same thing for the operation manager. We do have priority. You should set priority in your situation, which is very important. Alright, that's the end of today's class. See you guys on Wednesday.